3, 2, 1.
Hi, I'm Irina.
Hi, my name is Trent Norman. I work with the University of Academic Success program, and we're doing a series on astronomy. What? The universe is big. We're talking really, really big. And it actually takes quite a lot of imagination and study to realize this. It may be easy to just say it's large and move on, but most don't know how large means. But with the right tools and exercises, we can all come to realize that the universe is bigger than you think it is. Most of the universe hasn't been physically explored yet, but we can try comprehending it through astronomy and similar studies. It can seem abstract, but the study of the universe can affect not only the reality we currently live in, but the future one we build for ourselves. Astronomy can get tricky, particularly when it comes to comprehending large sizes and distances. Its sheer vastness is literally alien to us, and a useful way to begin to understand something that we're unfamiliar with is to compare it to something that we know. What makes this challenging is that these measurements start to fail us as the things we measure get bigger and bigger. Measurements eventually become too many numbers to write. It makes the process very tedious, and it makes it much easier to swap out the old comparative measurements with new ones. But we have to start somewhere. We can begin with a little measurement and work up to bigger objects, step by step, to make it simpler. Starting small, let's measure the size of a meteor. This may seem big when compared to a person, but compared to stars and planets, it's pretty small. This hypothetical meteor is 10 meters wide. That's the length of 2 small cars bumper to bumper. And for reference, if this meteor went hurtling towards Earth, it would just break up in the atmosphere and kind of fizzle out. A meteor would have to be way bigger to do damage, about 10 times larger than the current example. We asked various students what size a meteor would have to be to destroy life on Earth. This is what they had to say.
Would it be the size of the car, size of ASU Tempe, the size of Tempe itself, or the size of the state of Arizona?
Most interviewees picked,
I'm gonna say D.
It'd have to be the size of the whole state.
I'm pretty sure even small one can kill because of the heat.
I would say that it's probably Tempe campus.
Planet killer. Will it be B?
that's large, but not.
I'm gonna guess C, the size of Tempe.
Yeah, you're right. It is the size of Tempe.
C. That is correct, yes. Let's go. We've compared the size of the meteor to things we are more familiar with. And using the meteor's size, we should be able to start measuring bigger objects now. This is a technique that is used in many fields and goes by the name of comparative or comparison measurement. Art, for example, can teach beginner anatomy by using heads as a measurement to help scale drawings. The thing is, even when we're told the actual size of something, we don't really know it. You know, but don't really know. You know? You guys feel comfortable, you can close your eyes, but I just need you to picture in your head one galaxy. Pretty easy, right?
Yeah.
Pretty easy.
Pretty easy.
And can you picture 2 galaxies in your head?
Uh-huh.
I guess, yeah.
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 Let's go a little harder. Let's bump up to 5 galaxies all at once. Can you picture them in your head?
What about 10, 20, 25? About 100. Can you imagine
Not
100
even close
all
to
at
100,
once?
not even close.
How about 1,000?
Okay.
Million?
I think that is a little more than maybe I can visualize at once.
Not all at the same time?
No. I do a couple at a time, but not at the same
Not
time.
even like 100 or 1,000?
Not even close. I can barely get 10.
A little harder?
Harder, definitely
This
harder.
is getting like Doctor Strange.
Dr. Strange, yeah, it's got a little infinite multiverse. Yeah.
It's difficult.
The question is not whether people know what infinity is as a concept, but whether they can comprehend it on a personal level. It's like appreciating the size of the Grand Canyon during the first physical visit, instead of watching videos or looking at pictures. Being even vaguely aware of the size of the universe, and not just on a conceptual level, is an important step to help appreciate the scope and importance of things like space. For example, here's the Earth. Its surface area is over 500 million square kilometers large. That's enough room for you and nearly 8 billion other people. and counting. Moving on to the sun, it's 6 times 10 to the 15th square kilometers. That's enough to fit a million Earths. For reference, that would be nearly 8 quadrillion people. So what would be the space in between them? The distance between the Earth and the sun's core is about 93 million miles. That measurement is referred to as an AU in astronomy. This measurement doesn't just inform us about how far we are from the sun, it also serves as a comparative measure and really helps us tell where the other planets are in the solar system. These are where the planets are in our solar system. Now, how far do you think they are from each other? So just to kind of get a frame of reference for, do you guys know what an astronomical unit is?
An astronomical unit?
Yes.
It's a unit that measures something in space.
So this represents 1 AU. It's the sun. This is kind of like the marking here, and each one of these is like an AU. So taking the Earth here, where do you think it would go here? Like
Right here. 1 astronomical unit is the distance between Earth to the sun, so.
Oh, perfect. That's
I know this much.
I mean, like,
Sun, right?
yes.
All right.
That's correct. Awesome. Anything else, like Jupiter?
Yeah.
How many astronomical units do you think that is away from the Earth?
5.
You're right. It is 5 away.
What about Saturn?
I'm trying to remember, but it's a lot.
1, 2, 3, 4, 5, 6, 7, 8, 9. You're off by 1.
Oh.
This was 10 AU.
That's close.
It is 9 AU. It's close enough, actually. What about something like Pluto? Do you think you can put Pluto on here?
I'll put it for
So we've bamboozled you. So this board goes farther than the board. It's going to go way out here. And we're going to keep going. We're going to keep going. We're going to keep going. And Pluto's all the way out here. Compared to, now look at the sun and the Earth, and this is Pluto. I could tell you, what if I told you 100 million kilometers? Can you picture that?
no.
So to put it in simpler terms, we made the astronomical unit. So basically, it makes it simpler. So if I told you that the Saturn is 10 AUs away, you kind of like, yeah. You can kind of understand that's like a little easier to understand because it's much smaller, quantifiable number. And Pluto would be like 40 AU away, which is, much farther. And you're like, oh my God, it's a long ways. But you still understand the concept that it's like very far. And with Pluto, we've reached the edge of our solar system. And the nearest major solar system past that is 275,000 AU away, plus some change. Using the AU at this point would be like measuring a pool's depth in centimeters instead of feet. So we will be working with light years instead. Light years measure the distance of how far light travels in a year. It is about 6 trillion miles. In light years, the nearest solar system is about 4 light years away. And what we found is that a collection of stars in solar systems, which we call a galaxy, can be 100 billion stars big, making it nearly 53,000 light years wide. And then we have a collection of galaxies called clusters, and a collection of those called superclusters. This is a cluster. Now this is a supercluster. For reference, this is how big they are compared to all the things we measured before. So what comes after that? Well, that would be infinity. If superclusters weren't mind-boggling enough, what exactly does something that never ends even look like? Try this exercise. At night, find some distant place, far from the city lights, and lay on the top of your car. Or any elevated area like a bench or a hilltop. Lay down and look up at the stars that are far more visible without the light pollution. If you look just above you, there should still just be stars. And when you look down below you, even more stars. There should be a realization, at this point, the only thing touching the Earth is your back. That you're glued by gravity to a big rock floating in outer space, surrounded by the stars. And the rock we're on is a tiny, tiny part of this growing universe. And yet, humans have never been physically farther than the moon. So how do we know any of this? Well, aside from comparative measures, astronomy uses so many other tools and techniques, and the study of the universe and its celestial bodies can be incredibly rewarding and interesting, and we hope you will go explore even more. Thanks everyone for watching this episode of Afterclass Companion. We hope it was fun and even educational in some ways. If you're interested in seeing more videos like this, send us a like, subscribe to our channel, or comment.
Thank you.
Thank you. It's very interesting to learn about.
Do you guys like anything about astronomy? Anything that interests you about our space and just like life beyond us, you know?
Shooting stars there in America. What amazed me even more was the scary stuff. Only because I was like, oh, the what if scenarios.
It's sad. I was so happy. Now I'm gonna think about planet kill.
I'm more scared about the end of the world now, so thank you a lot.